Hello, my name is Michael Skipper, and today we're going to be discussing a case study analysis for Swoop Solutions, ultimately building an ER diagram in preparation for building a database. Swoop Solutions. Phase 1, the description. Swoop Solutions is a luxurious hotel company with several locations, offering elegant rooms and various amenities to customers during their stay, where a full-time staff is always available to assist the customers. Additionally, customers can place reservations ahead of time or when they arrive. Swoop Solutions is going to need to keep track of all of these things. Phase 2, the single entity. Swoop Solutions must keep track of a lot of things in order to operate smoothly. All of the attributes of Swoop Solutions are contained within this entity called the single entity. From here, we can select certain unique keys as the candidate keys. Phase 3, the candidate keys. So the candidate keys are the keys which uniquely identify each row in a relation. We must eventually choose one candidate key among the rest, which will become the primary key. And in a well-formed relation, every determinant is a candidate key. So the candidate keys that we've selected from the single entity are company ID, employee ID, hotel room ID, customer reservation ID, and customer payment ID. Phase 4, the functional dependencies. First, we must contemplate all the possible functional dependencies which may exist in the single entity. Well, a functional dependency is a relationship which occurs when attributes can be determined by other attributes. The first functional dependency that we derive is rather monstrous. Company ID determines all the other attributes in the entity. So company ID is the determinant of this functional dependency. We read this as company ID determines employee ID, employee hotel location, employee job title, employee first name, and so on through customer status. But we're not done yet. There are more functional dependencies. We also notice that company ID, employee ID, hotel room ID, customer ID, and customer reservation ID, and also customer payment ID can each be used to determine a variety of other attributes. They are all listed here. Again, we read this as employee ID determines employee hotel location through employee city. Hotel ID determines hotel room ID through hotel phone number. Hotel room ID determines hotel room floor number through hotel phone number. Customer ID determines customer payment ID through customer status. Customer reservation ID determines customer reservation submission date through customer reservation comments. And customer payment ID determines customer payment credit card number through customer payment status. Notice, every determinant here is a candidate key. Now, we must identify the partial dependencies. Well, there are no partial dependencies because we don't have any composite keys. So now we must identify the transitive dependencies. A transitive dependency exists when a situation occurs in a relation of 3 or more attributes, such that attribute A determines attribute B, and attribute B determines attribute C, thereby asserting that attribute A determines attribute C. So we read these functional dependencies as company ID determines employee ID, customer ID, hotel ID. Employee ID determines employee hotel location through employee city. Hotel ID determines hotel room ID through hotel phone number. Hotel room ID determines hotel room floor number through hotel phone number. Customer ID determines customer payment ID through customer status. Customer reservation ID determines customer reservation submission date through customer reservation comments. And customer payment ID determines customer payment credit card number through customer payment status. These are the transitive dependencies. Implementing the normalization process, we split up our old functional dependencies. Now we're left with company ID determines employee ID, customer ID, hotel ID. Employee ID determines employee hotel location through employee city. Hotel ID determines hotel room ID through hotel phone number. Hotel room ID determines hotel room floor number through hotel room floor price. Customer ID determines customer payment ID through customer status. Customer reservation ID determines customer reservation submission date through customer reservation comments, and customer payment ID determines customer payment credit card number through customer payment method. Resources, steps to a well-formed relation. This is the normalization process taken directly from the textbook. Phase 5, the primary, composite, and foreign keys. Each of our functional dependencies corresponds to an entity. Each of our entities will have a primary key, selected from the candidate keys to uniquely identify all of the other attributes in the entity. We place the values from one relation into a second relation to represent a relationship using the primary key values of the first relation. The attribute in the second relation that holds these values is referred to as a foreign key. A composite key is a key that contains two or more attributes. We have none of these. So I've listed the primary keys: company ID, employee ID, hotel room ID, customer reservation ID, customer payment ID. These are each going to be acting as a primary key in each of the entities in our final ER diagram. The composite keys, there are no composite keys. The foreign keys: employee ID, hotel room ID, customer reservation ID, and customer payment ID. These are also going to be in the ER diagram. Phase 6, all of the entities. So now we have all of our entities together. We have payment, employee, customer, reservation, room, hotel, and Swoop Solutions. Phase 7, determining strong and weak entities. So a weak entity is an entity that cannot exist in a database unless another type of entity also exists in that database, whereas a strong entity does not depend on the existence of any other entity. Let's categorize our entities. Well, Swoop Solutions is strong, employee strong, hotel strong, room strong, customer strong, reservation strong, payment strong. They're all strong. Phase 8, determining ID-dependent entities. Well, an ID-dependent entity is an entity whose identifier includes the identifier of another entity. All ID-dependent entities are weak entities, though not all weak entities are ID-dependent. These are called non-ID dependent weak entities. However, this assessment is for weak entities. All of our entities are strong. Phase 9, cardinalities and types of binary relations. There are 3 types of binary relationships: one-to-one, one-to-many, and many-to-many, classified by their cardinalities. Cardinality is just another word for count. Relationships have maximum and minimum cardinalities or counts, which set their respective upper and lower bounds for the number of entity instances which can or must participate in a relationship instance. So we write out what these are here. Swoop Solutions, an employee, the relationship between these is one-to-many. The relationship between Swoop Solutions and hotel, one-to-many. The relationship between Swoop Solutions and customer is one-to-many. The relationship between hotel and room is one-to-many. The relationship between customer and payment is one-to-one, and the relationship between customer and reservation is one-to-many. Phase 10, the ER diagram, or the entity relationship diagram. So the cardinalities and types of binary relationships that we discussed on this slide are now present in this ER diagram and shown using crow's foot notation. This little thing that looks like a crow's foot. Entity relationship diagrams help to visualize data and serve as a structural diagram for the design of a database. This is what we're going to be basing our ultimate database off of for Swoop Solutions. As you can see, the primary keys and the foreign keys are all here. Team responsibilities. All the team members, namely Noah Ramirez, Lee, Lou, and Michael Skipper, have worked together to complete this project by collaborating on all of the bulletin points in the description for the case study and translating these guidelines into an ER diagram that captures the design of a database. I developed these slides in this presentation independently, however. And these are the references that I used throughout this presentation, including the textbook. And in conclusion, we have embarked on an extraordinary adventure. We visited the depths of database management and emerged with our own ER diagram to assist in the construction of an actual database for Swoop Solutions. Now we're ready to design our database. Thank you very much.